Okay. Let's start taking a look at this section. That first theorem there, polynomial difference theorem, it seems like it's a lot of stuff, but once I show you like an example of it, it's not as bad as it appears. So it just says like a function with equation y is equal to f of x, so just f of x basically, is a polynomial function of degree n. So n is what we're trying to figure out, like the degree of whatever our polynomial it is. If and only if for any set of x values that are consecutive terms, so consecutive just back to back, so like first term, second term, third term, and so on, of arithmetic sequence, the nth difference of the corresponding y values are equal to or are equal and non-zero. Like I said, that's very confusing. I'll show you what that kind of looks like. This is in your package, just one of the extra pages. It's just the example that the book kind of had. So basically what they're going to do is they're going to give you like some sort of table like this where you got like a row of x's, row of y's. These are kind of like your term numbers up top here, and then whatever gets kicked out of whatever you're looking at is down here. Basically what you're doing is you're just finding the differences or just subtracting the two y values that are like next to each other. So like here you're just taking like 9 minus 2 and getting 7, 16 minus 9 and getting 7, and so on there, basically just subtracting those values. And then what's always going to happen with these is once you do it so many times, you're always going to end up with like the same number happening over and over again. However many times you have to do this out, that's what your degree is. So in this case, because we only had to do like the subtracting out once and got all to sevens there, the degree of this one would just be 1. And we can actually see that from that equation as well, but most of the time you're not going to have that equation or that function there, and you have to figure out that equation or function, and you do that by figuring out what that degree is first. So like same thing would happen with this one here. So you do your subtracting, so like 4 minus 4 is 0, 4 minus, or 6 minus 4, 2, and so on there, you just do it out. But when you get to those, it's not the same number, so then you have to keep subtracting until you get the same number, so then you just take those numbers, subtract out, then you get down to 2. So because you had to do that subtraction stuff of the rows twice, that would mean that that has a degree of 2. And then here you can see from that actual equation or function that they kick out, it does have a degree of 2 because that's the highest power. But again, they're not going to give us that. That's what we're going to work on coming up with. But we have to figure out what the degree is first by using that polynomial difference thing. But all it is just subtracting the numbers, basically. Most of the numbers, not all of the numbers we look at, but some of the numbers we look at are going to be like these, I don't know how you really say this, figure-it numbers or something like that. Basically, it's just numbers that come from pictures. Like this is like the triangular sequence where you got like 1 dot and then 3 dots and so on there. So if they were going to write this as a chart, basically you would have like t as your first term, so it would be like a 1 on the top of the chart, and then your number that gets kicked out is a 1, so a 1 would be below that. Second term's 2, and then 3, so a 2 on the top, 3 on the bottom, and then so on there. So if they, just give you something like that, like a picture, you just come up with those kind of like ordered pair numbers and then do your subtracting. But it's basically just a pattern of things. Now, it can be two-dimensional like this. It can also be three-dimensional, so they might also give you some, like they think even on this little page here, they kind of give you like a three-dimensional example. So you might have something like that too, where like they give you like a pyramid type looking one, and like your first term would just be the 1, second term would be 4 because there's 4 dots there, and then so on. So you might also have it three-dimensional, but like I said, if you can come up with the numbers, it's not too bad. And then what we're going to end up doing is once we find our degree amount, we're just going to use like our regression stuff to figure out a good equation or function for this. So we've worked with like line reg and quad reg before. I don't know if you guys done cubic or quart reg. Basically, it's the same thing as the line reg and the quad reg, where you just like type this stuff into the list, come up with L1 and L2, go to your regression types, and then you just pick one of these. So what we're going to do first is we have to figure out what degree our actual situation is, and then like if it was like the third degree, we use cubic reg. If it was the second degree, we use quad reg. And then when you kick out your answers, like for line reg, you would just get an A and a B value. You just put those numbers in there. If it's like quart reg, you're going to get an A, a B, C, D, and an E, and you would put all of those into your equation. But like I said, there is a way to do this by hand, but it's a living nightmare because it takes forever. You probably did it a little bit in Algebra 2, but probably only with like quadreg and not past that. But if you do it for like quartreg, you basically get these huge matrices, and it's just a lot of work to type it all in. So I'm just going to skip that and just show you how to do it with the other stuff. So let's go to our example packets then. And we'll look at, there's two examples. I'm going to change the directions on the first example because the first example is, I'm pretty sure, where they want you to do it out by hand. I don't want us to do this out by hand using matrices. So I'm going to cross out that whole second sentence there. We're still going to use those numbers, but instead of doing that, we're just going to start by finding the degree. So I'm going to change this question to what is the degree of the polynomial? And technically we don't have a polynomial or anything yet, but if we had a polynomial based on that, we're just finding the degree of that. Like I said, the other thing is calculating it out by hand with matrices, and I don't want to do that. And I don't think there's any questions on the assignment that ask you to do that. You can use the quadreg and that kind of thing for all this. So what we have to do here first is we have to come up with like our table of numbers. So these are like our octahedral numbers. Oct is just 8. So the first one's just 1, 6, and so on there. So I'm just going to start by making myself a little table. And our first thing, sometimes they'll use x, sometimes they'll use n. The book used n on this one, so I'm just going to use n. And then for our function notation, they just use p of n. Again, it could be like f of x or whatever. It doesn't really matter. Top row is always going to be our term number here. So like this is the first term, second term, third term, and so on. So it looks like we've got 7 of them. And then the bottom row would be the numbers that kicked out based on that term number. So you would just do like the 1, 6, 19, 44, 85, 146, 231. And then to find our actual degree before we can use our calculator to do stuff, this is where we're looking at like our consecutive values and subtracting those. So like here, if I did like 6 minus 1, I get 5. If I do 19 minus 6, I get 13. 44 minus 19, I've got 25 on my sheet. 85 minus 44, I got 41. 146 minus 85, I got 61. And then for the last one there, 231 minus 146, I got 85. And again, you're just subtracting those values. So then obviously looking at those numbers, they're not the same number, right? So then we just have to do this again until we get a row of all the same numbers. So if we do like 13 minus 5, that would be 8. 25 minus 13 is 12. 41 minus 25 is 16. 61 minus 41 is 20. And then 85 minus 61 is 24. And you can probably see that that's going to kind of pick up a little pattern there. So see how now it's counting by 4s there. So now with these, if you subtract them, they should all be 4 apart from each other. And now that we're down to like all of the same number there, we're done. So that's going to tell us our degree. So here we did this out 1 time, 2 times, 3 times. We found those differences. So if we did that 3 times out, that would mean our degree of that polynomial. We don't know what the polynomial is yet, but we know it has a degree of 3. Now why we have to do that is because if we didn't do that, we don't know which of these 4 things to pick if we don't know what the degree is. So now that we've just figured out that the degree is 3, to find our actual equation, we're just using the cubic reg button. Okay, so and that's actually example 2 is us actually just figuring out like what the polynomial for that would be. So what you do on this, if you don't remember, you go to stat, because we got to type it into our list, so stat and edit, and then just clear out whatever you got in your list. To clear it, remember you got to go up to the title, hit clear, and then arrow down, and it should clear. And when you're typing your stuff, this whole top row here is going to go into L1, bottom row is going to go into L2. Okay, so you're just typing like 1 through 7 in L1, and then in L2, you're just typing those corresponding like P of n numbers that got kicked out. Just getting those typed in. then once you get them typed in, then you go stat again, and this time we want to do a calculation, so we go over to calculate. Like I said, we've used the len reg and the quad reg before. The cubic reg and the quart reg should be the ones underneath that. They don't have any past that. I assume it's just because it's like a pretty hard thing to do out, so the calculator probably just doesn't have that full capability to like do it, like keep doing it out for more stuff than like powers of 4. I think you can do it past that, but our calculator can't, so all our stuff will be 4 and under. But we're going to use cubic reg on this one because our degree was 3, so that matches with cubic. So then you just hit enter. If you got a new one, it asks you questions like L1, L2, whatever. Just make sure like whatever your X value is, L1, whatever your Y value is, L2. Then you just go down, I think it says like calculate or something like that. Just go down to calculate, hit enter. Mine, it automatically selects L1 and L2. So I hit calculate. And then what it's going to give you, I'm going to show you how to write this out in a couple different ways here. So because it's cubic reg, your highest power there is going to be 3. That's why we had a degree of 3. And you should have 4 different numbers here that you're going to write out. So I'm going to write them all out first here. So we get like y is equal to, that first one there is for the a is like 0.6 repeating. I'm going to do it as 0.6 repeating just to be like specific, you know what I mean? If you know it's that, I would put it as that. Plus, oops, I need my x to the third in there. 0.6 repeating x to the third plus my b value is 1.04. And then that's actually times 10 to the negative 11. And I'm going to put that in parentheses just because technically all that goes together as like its own little number there, and I'll show you more with that in a second. That goes with the x squared because that's our b value. Plus, and then for our c value, we got 0.3 repeating. So 0.3 repeating, and that goes with the x. And then for our d value, we've got, and again, I'm going to put this in parentheses because it's scientific notation again. So 2.9 times 10 to the negative 11th. So I wouldn't say that this answer is wrong, but this is not the answer the book has. And what they do in the book, and I don't know for sure if this one is better or if the one that the book has is better, but what they actually do here, I'm going to do this in a different color just so you can kind of see it. This value and this value, when they're in scientific notation like that, are super, super, super close to 0, because like this one's like point, then there's 10 zeros, 104. Isn't that like super, super, super small? So what the book does, and same with this one here, when it's like that decimal to like negative 11th, it's just like super, super small. Because those values are actually super close to 0, they actually just get rid of them. Okay, so I'm just going to write a note here of why we're getting rid of it. So that one and that one are like very close to 0. So they actually just get rid of them because they must not hold enough relevance because of how close they are to 0. So what they actually do for their answer in the book is they write it out as like y is equal to the 0.6 repeating x to the third. Like I said, they value that so close to 0 that it's not relevant, so they get rid of that. And then the next one there would be like the 0.3 repeating with the x, and then that last one, same thing. It's so small they don't hold any value to that, so they get rid of that one as well. So this is actually what the book has for its answer instead. You could also do these as fractions if you wanted to. So like that would be like 2/3 x to the third, 1/3 x, and technically you could put them in a different fraction with 3 on the bottom or whatever. I don't really care which way you do it, because I know sometimes it's like, ooh, should I get rid of that, not get rid of that? All of the answer keys, I assume, are probably going to get rid of those ones where it's like close to 0. On a test, I don't really care. Like on the test, if you wrote it out like this, or if you wrote it out like one of those, I don't care. But like I said, I'm assuming that the book answer keys and the worksheet keys are probably going to write it out more like this and get rid of those. But because that is what the calculator actually kicked you out, I would be cool if you left it like that on the test. Does that make sense? And again, I don't know which one's better per se. I would assume that this one's maybe a little bit more accurate, but I don't know that for fact. Or if it's just the calculator can't do it exactly, and they're just putting that in there, but either of those are fine. Does anyone need the actual steps for the, like, stat, edit, any of that stuff? Okay, I can write them down if you need, but I figure we've done it quite a few times. So really that's it. That's basically the gist of it. So basically just finding the degrees if you need to, and then just typing the stuff in the calculator after you know which type it is. Like I said, there is a way to do it by hand, but we are not going to do that because I don't want to, and Mr. Kasich said no, so. that's that.